I recall that we met last week, and as part of the usual thing, we had an interesting lecture. Or will somebody move to recap what we did last week, and then we move on? Yes.
Okay. Good morning, sir.
Yeah, good morning, Honorable.
So please, last week we spoke about gases. Then we said gases are needed by the human body for survival. Then the type of gases were basically oxygen and then carbon dioxide. Then we made mention of some importance of oxygen. One, maintaining vital organs such as brain, liver, kidney, etc. Then we also said oxygen is a fuel for aerobic cellular respiration, which converts nutrients, that is glucose, into energy. Then we made mention of some sources of oxygen, which we said oxygen is mostly gotten from the atmosphere. Then we spoke about carbon.
Hello, Francis. Are you there?
Hello, sir. Can you hear me?
Hello, Francis. Did you hear me? Hello, Mr. Francis.
Hello, sir.
Please go ahead. We are listening.
Okay. So we made mention of carbon dioxide. And then we made mention of some importance of carbon dioxide. Then we said carbon dioxide, then the importance of carbon dioxide maintains the pH of the body by serving as a buffer. Then carbon dioxide also stimulates the impulse for breathing. Then we talk about how carbon dioxide is also acquired by the body. We said through inhaled air and then through metabolic processes. Then we also talked about minerals, where we mentioned metals and non-metals. Then we gave some examples of the metals, which include zinc, copper, magnesium, cobalt, iron, etc. Then we also mentioned some examples of the non-metals, which include chlorine, sulfur, phosphorus, etc. Then we said iron is required through diet. Then the importance of iron, we made mention of how iron is required. Then we said it is required through diet, especially leafy vegetables. Then we also mentioned some importance of iron, in which we said it combines with hemoglobin to transport oxygen to various parts of the body. Then we said when iron is stored, mainly in the liver by a process known as ferritin. And then when it is transported in the blood, it is known as transferrin.
Okay, let me explain something here. Let me clarify something. I said that iron is stored in the body in the form of ferritin. So it's not a process. It is stored in the form of ferritin.
Okay, thank you for the question.
Yes, ferritin is a protein which is modeled to be able to store iron. So that's basically what I had said. And
Okay.
then it is transported in the blood as what? Transferring. You don't have free iron in the blood. It is transported by a particular protein called transferrin. So if you want to know somebody's iron status, you go for the two. You measure ferritin levels and transferrin level. So the ferritin is the reserve. The transferrin is the ones that are being circulated around, so that when you add them up, you know how much is the iron store in the body. Are you okay?
Yes, sir. Thank you, sir.
On a lighter side, you can consider another protein called hemosiderin, but this is usually constitutes a very small proportion of body iron. It's also a storage form of iron. Hemosiderin, HEMOSIDERIN. I think last week I touched briefly on that. I didn't stress on it, but I did touch on that. All right. Yes, Francis, wrap up.
So I think basically that is what we talk about. And then you gave us a reading assignment to find the physiological roles of the following minerals in the body, which include calcium, selenium, chlorine, fluorine, potassium, and then sodium. So basically, this is what I learned last week. Thank you, sir.
Okay, that's wonderful. Thank you very much. Maybe let's see if we can get another person. Francis, do you have a friend, maybe a brother, sister, in a class? Yes. Hey, Elonye, am I right, Mr. Emmanuel?
Yes, sir. Good morning.
Yeah, good morning, Honorable. Happy Vows Day.
Sir, same to you. I believe you'll be sharing chocolate for the class today.
Oh, Jesus. I also think the class will be sharing chocolates to me, so you can imagine.
All right, sir.
So
the bit I want to add to Francis' one was I think you also touched on organic biomolecules, and then you gave few characteristics of them. Said they contain carbon, hydrogen, and oxygen. Their reaction in cells are mostly hastened by introduction of some enzymes. And then I think you mentioned that that they also exhibit stereoisomerism.
Yes, beautiful.
And they said that, yes, and that means that they exist in multiple forms. So, and then finally, you said they also dissolve better in non-polar solvents. I think you gave some examples of them. So I think that was it. I think that was where we ended with the lecture last week. Thank you.
All right, that's beautiful. Thank you very much. So let's roll with today's lecture and let's enjoy. Please kindly pardon me. I have something urgent to attend to, but in the meantime, kindly listen to this so that on my return, I will explain this. Okay. All right, so let's go. Please, I hope you keep making notes anyway.
Yes, sir.
All right. Now, look here. You can see these loose hanging structures extending from these transmembrane proteins. Are you okay? These are transmembrane proteins. You can see some loose hanging carbohydrates. Are you okay? Oligosaccharides and all that. These are what we refer to as what? Receptors. They are just flagging around and they enable the cell to be able to pick up stimulus, either chemical messengers like hormones, or they are able to pick up nutrients. Are you okay? Sometimes some of them are even able to pick up ions, are you okay, and neurotransmitters for nervous transmission. Are you okay? So this is what I was referring to, the fact that carbohydrates are capable of acting as what? Receptors. Are you okay?
Yes, sir.
Good. As we get along, if you have a question, you can ask. Then they also serve as what? Raw materials, the synthesis of other higher forms of what? Carbohydrates. Are you okay? So, for instance, you can talk about the use of carbohydrates for the synthesis of what? I mean, we can talk about using glucose to synthesize what? Glycogen. Are you okay? We can talk about using galactose to produce what we call milk carbohydrate. Are you okay? What you call lactose. So here, most often the buildup of large complex biomolecules from simple ones often occur in the Golgi apparatus, and oftentimes they are secreted either into the cell or outside of the cell. Usually inside the cell, they are stored in different forms, but outside of the cell, they may appear as a chemical messenger to elicit function in different places of the body. Are you okay? So that's what I would say in brief. Any question on this? Okay, so move on to the next, which has to do with what? Common characteristics of what? Carbohydrates. Among other things, most of the simple forms of carbohydrates taste sweet. Madam Christiana, your hand is up.
Yeah, sir, good evening.
Yeah, good evening. It's Boachua.
Please, can you go over? I don't understand.
Which one don't you understand? I'm sure you just joined us. Hello, Madam Boachua.
Yes, please.
I'm sure you just joined us, right?
No.
So what's your problem, please?
He said, please, I don't know, but I'm not getting it.
Yeah, what point didn't you get? So I know.
The functions of carbohydrates and then before carbohydrates.
Yeah, I was saying that principally, or among other things, carbohydrate can serve as a nutritional source. And I think this is very, very clear. Are you okay? It's a nutritional source. When you take in, it's meant to produce energy for you. That's why when you are tired, you just take a sip of what? Glucosate or whatever. Glucosate. Yes. Sometimes when your patients are not being fed, maybe with solid food for one reason or the other, a lot of the time, what you put them on infusion, and during the infusion, you administer what? Simple carbohydrate. Usually it's glucose, or probably if there's any other simple sugar you use. Are you okay? I don't know if you do that in your facility.
Yes.
You do that, right? Miss Wachua.
Yes, please, we do.
Okay. So why do you administer the glucose instead and not any other? Because it's readily utilizable. Are you okay? The body can readily work on it and then generate enough energy. So even though the patient may be famished, at least within
Yes.
they will still keep on, are you okay, and be very strong to treatment. Then they also contribute to structure. And with structure, I was talking about the fact that if you look at plants would have cellulose in their cell wall, which will contribute to rigidity of what the plant and fixed, are you okay, in shape. In the same way, the fungi, insects, and crustaceans we mentioned also contain what? Some kind of carbohydrate, which we call chitin, and that contributes to what? The structure. Are you okay? Of course, you know shrimp is not soft. It's a bit hard, isn't it? The crab appears as a very, very aggressive and resolute animal, but much of its sort of bone, in quote, are made up of what? Chitin. Okay. Then we also spoke about the fact that they can function as receptors. And I showed you a diagram of glycoproteins usually flying up, are you okay, as distensions from plasma membranes. And they help the cell to respond to what? Available stimulus nearby, are you okay? Whether it's temperature, whether it's chemical stimulus, are you okay? In a form of neurotransmitters, in a form of poisons, in a form of even pharmacological agents, and so on and so forth. Are you okay? And then lastly, they also serve as raw material. In other words, sometimes they serve as building blocks. So simple carbohydrate can be used to build complex and large forms of carbohydrate. Are you okay? Is it better now?
Yes, please.
All right. So maybe a practical example could be this one. We talk about glycogen. Glycogen contains a lot of what? Glucose, and these glucose molecules are held one to another, end to end. Are you okay? We call it polymerization. So once they get polymerized, we produce a lot of this glycogen. Predominantly they are often stored in the liver and in the muscle, and they can be called on during times of hunger. Are you okay? So during fasting days, when you are not eating, the body can now resort to the glucose which you stored as glycogen in the liver for energy to keep you going. Madam Rebecca, your hand is up.
Sir, please, your screen, can you zoom it a bit? The ones that, I think the summary side, yes. I couldn't see it.
Which one? This one?
No, the summary side, before the slide.
This one?
Yes. I can't see anything. Can you zoom it a bit?
Let me see.
Yes, please. It's very blurry.
It's blurry,
What? Okay.
It's very blurry.
Yeah. I mean, I try and zoom it from your end. Are you okay? Are you okay?
So please, when you zoom it, you can't see it well.
Really?
This
Yes,
particular
it is so blurry.
Yes, when you zoom it, you can't see it.
Yes, this one, even after zooming, it is still blurry.
Very blurry.
Is it better now?
No, please, it's the same.
Okay, you will return back to it. It's just a summary of all that we'll be looking at today. But along the line, I think if you can't see it so clearly, at least you can get the message. Are you okay? So let's keep. All right, God bless you. So let's look at some characteristics of carbohydrates. Number one, among other things, we say that they are what? sweet to taste. And that's why most carbohydrates are loosely referred to as what? Sugars. Are you okay? From the Latin word saccharides. Are you okay? That's something that tastes sweet. Okay, and their sweetness levels are not the same. You could realize that from this chart, fructose appears to be the most sweet carbohydrate or simple sugar, followed by what? Maybe glucose, sorry, yeah, sucrose. Are you okay? Sucrose. It's 100. Are you okay? Not 1, 2. It's 100. Then glucose follows, and then finally lactose and galactose. Are you okay? As a rule, what I would say is that usually most of the simple forms of carbohydrate, like glucose, fructose, galactose, and all that, are very sweet. But the complex forms tend not to be too sweet. I'm sure some of you mischievously get starch, unsweetened starch. Has anybody tasted one? Or just for simplicity, has anybody tasted custard without sugar? How does it taste?
Oh, it's a bit sweet.
Custard is sweet without sugar.
It's not sweet. It's not sweet. It's not sweet without sugar. It's not sweet.
Yes. Because custard contains predominantly starch. Are you okay?
Yes.
It's very rich in carbohydrates. It's not sweet as compared to glucose, fructose, and all that. In fact, fructose is sweet that it gives a bitter aftertaste. That's how come sometimes when it tastes honey, to some extent, it appears a bit bitter after the taste. I'm sure some of you may have realized that.
Yes, sir.
Mm-hmm. The next characteristic is mutar rotation. Shall we all say it together?
Mutar rotation.
Press it. Last one. Mutar rotation. Yeah.
Rotation. They are behind. You are not letting them in.
Oh, I have issued.
Okay, thank you, sir.
You're welcome. Yes, Madam Christiana, your hand is up. Okay, Ama Dufie. Mrs. Dufie, please, let's hear.
Okay.
Hi. Yeah.
Hello, sir.
Yeah, Miss Dufie, I'm listening to you. Please go ahead.
So please, we started with characteristics of carbohydrates, which was most abundant and contains carbon, hydrogen, and oxygen. And right now we are characteristics of carbohydrates, and I'm a bit confused.
Oh no, those ones were just basic information about carbohydrates. They were not necessarily characteristics. In fact, these are the real chemical. Okay, let me say that those information were general characteristics. Now, what we are looking at are chemical characteristics. Is that a chemical characteristics?
Okay, thank you very much.
You're welcome. Yes, Miss Boachua.
Come on, they'll bake.
Okay.
Okay, Madam Boachua, your hand is up. Yes. Okay, Roberta.
So I said it.
Yes.
Hello, sir. Hello, sir. Please, the sucrose, the percentage, is it 100% or I didn't see it well.
You mean the
sucrose?
It's 100. It's 100.
It's not 1.00, it's 100. I think I should have.
Thank you.
All right. Can I go on?
Yes, please.
Wonderful. Thank you. So we look at mutual rotation. What does mutual rotation mean? It means that carbohydrates are capable of transforming themselves from one form to what? And if you look here, this is one form of glucose. We call it alpha D glucose. Are you okay? It can open up. I understand perfectly that many of you are not so chemistry inclined, so I don't want to bother you with the chemistry mechanism and all that. But we can't also do biomolecules without a bit of it. So please follow me. What we are saying is that some carbohydrates are capable of what? Transforming themselves from one form to another. Here we have alpha D glucose. Are you okay? Please pay close attention to this OH group. Can you see here? You can
Yes, sir.
pointing down.
Yes, sir.
And when it points down, I'm talking about this first OH group. The OH group that's bonded to this first carbon. There's a carbon here.
Okay.
Okay, there's another carbon. Everywhere you see a joint, there's a carbon there.
Okay.
The OH is pointing down, and that's why we call it what? Alpha. Can you see that?
Yes, please.
If you leave a solution of alpha D glucose to stand, it's capable of what? Opening itself up. As you can see here, there's a ring form. Now it opens itself up in an open chain. Are you okay? And then it closes up again. But in closing up, look at the orientation of the OH. It has been pushed what? Upwards. Can you see that?
Yes, sir.
Now, if it happens,
Yes, sir.
we call it what? Beta. So there's beta D glucose and there's an alpha D.
Alpha D.
Does it make sense?
Hello,
sir.
Sir, please, can you take it again?
Let's hear you.
Some people are back.
Yes, I've been admitting them. Okay. I've been admitting them. They show up on my screen and I keep admitting them.
Okay, thank you very much.
You're welcome.
Sir, please, can you take the...
Hello, sir.
Hi, Madam Abiba.
Sir, please, I was wondering if you could leave the slides after the lecture so that we'll go through them this night because our network has been misbehaving.
All right, but I can hear you very clearly. Can you?
Yes, sir, but
Hello, Ajay. Mr. Emmanuel. Hello, Emmanuel, your hand is up. Hello, Emmanuel Ajay, please, your hand is up. May I know your concern? Okay. All right, if there isn't, then let's continue. Okay. Yes. I think somebody raised their hand up. Can I hear you? That's Ima. Hello, Emmanuel. Hello, Mr. Emmanuel. Please, can I hear you?
Please, good morning.
Yeah, good morning.
Yeah, please, I want to ask what you were just saying. Is it the same as alpha numeric glucose and beta numeric glucose?
Say that again.
I say, please, what you were saying, is it the same as alpha numeric glucose and beta numeric glucose?
Okay, normally we don't bring the term anumeric, okay, just alpha or beta, because the statement alpha or beta suggests that they are anumeric. Are you okay?
Yes, sir.
So anumerism is just a term used to describe two or more alternative forms of the same biomolecule or same molecule, okay, in chemistry. So we say alpha glucose or beta glucose, okay.
Okay, sir. Thank you.
Yes. Many times people barely read, but if you buy any glucose, raw glucose, okay, I'm talking about the glucose powder, okay. If you pick one and you read on the label, you will see a lot of some of these writings on them. Alpha G plus glucose. And they are not for nothing. Okay. They are not for nothing.
Okay, sir.
They are just to let you know which chemical form of the glucose is being used. And this is important because molecularly, our body work with a particular anumeric form and not the other. That's why some carbohydrates are nutritive to us. Are you okay? If you take leaves,
okay, sir.
Plant leaves contain a lot of, they are a rich source of carbohydrate. That's why ruminants, are you okay, eat a lot of leaves and grass, because that's the main source of carbohydrate for them. But the point is, they are not beneficial to us as humans, and they don't constitute a good source of carbohydrate for us because the form of carbohydrates in these leaves are not ones that our body enzymes can work with. Are you okay? They are not ones that our body can work with. And so even though they are available, they are not useful. So you take them and they only add bulk to stew, and then you just defecate it out. But when the ruminants take them, they're able to grow and develop from it. Are you okay?
Yes, sir.
All right.
Thank you, sir.
So that's about that. All right. And this phenomenon is also highly applied in drug design. I'm sure you may do this in pharmacology, but in the design of drugs, it's very important that you configure the drug in a particular structural form that is compatible with our metabolic system. Because after the drug is finished working, the body now has to detoxify it so that it can be removed from the body. And if that doesn't happen, the drug is going to accumulate. And even if it's harmless in the beginning, like they say, too much of everything can be bad. So accumulation over time can begin to influence or interfere with other metabolic processes and cause problems. Okay. So to avoid biotoxicity, you have to formulate the drug in such a way that after it's done with its work, the body's metabolic system and enzymes can work on it and then clear it from the system. So all the para and other things, once you take them in, they come out through urine in different forms, the antibiotics and all that. Okay, and that is what makes them less toxic and less harmful to our body. Is that why I answered your question?
Yes, please. Thank you very much.
Okay. Right. I hope you are jotting down a few things.
Yes, please.
All right, good. So let's continue from where we took a pause.
Like from the beginning, it has been misbehaving, but right now it's getting better.
Okay, so let's hope it continues so you can enjoy the lecture. Okay.
Okay, thank you.
All right, Madam Roberta.
Hello, sir.
Yes.
Hello.
Hello.
Please, so with the mutant rotation, as part of the characteristics of the carbohydrates, I didn't get it well. So how do you explain, like, if you are asked to state the characteristics and explain?
Oh, but I guess I just finished with an explanation that
yeah.
It's a phenomenon. Are you okay? Are you with me?
Yes, please.
Yes, sir. It's a phenomenon which deals with what? The concept that carbohydrates are capable of what? Chemically transforming themselves from one form toward another. And there's a clear example. Are you okay? I don't want to go into the technical nature of it. It would really throw many of you away. Okay, so in just simple sense, it's just a concept that deals with the carbohydrates or simple forms of carbohydrates are capable of transforming from one form to another. Are you okay? Hello?
Yes, sir.
All right.
So it's a phenomenon in which the carbohydrates are able to chemically
transform themselves.
Okay.
To another. Not chemical, but let's say structurally. I prefer that one because sometimes chemically they may become something else, which not into the description of rotation. So let's say that they turn themselves structurally from one form to another. Are you okay?
From one form. Okay. Yes, sir.
Structural. Okay. Another. So here we have just like an alpha D group transforming itself to become a beta D group.
Oh, okay, beta group. Okay. I now get
what you see here are the characteristics of the alpha D. The melting point for alpha glucose is what? What's the melting point here?
It's 146 degrees.
Okay, how about the beta D?
150 degrees.
So you can see that they are not the same.
Yes.
Now, what you are seeing as numbers here, this plus, it means that they can bend the plane of polarized light. Okay, we call it optical activity. It means that they can bend the plane of what? Polarized light when exposed to it. So look at the angle. This one can bend it to what? 112 degrees. How about this one? It can only bend it to what? 18.7. Are you okay? Hello, class. Are you with me?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Generally, what we are trying to say is that during mutant rotation, simple forms of carbohydrates are able to transform themselves from one structural form to another by opening their chains and then cyclizing again. Are you okay? What I mean by cyclizing is that they open the chain and then they recyclize. They become a cycle. Are you okay? Like you can see here. Okay. All right. So that's about that. Number 3, simple forms of carbohydrates are capable of what? forming glycoside. Mrs. Boachua, your hand is up.
Yes, sir. Sir, please, the stereoisomerism and then the mutual rotation, is there any difference?
The
stereoisomerism and then the mutual rotation. Is there any difference?
Yeah, the stereoisomerism, mutual rotation is actually a form of stereoisomeric property. Are you okay?
Oh, okay.
They are not strictly the same. They are not strictly the same. But then, they are one form of stereoisomerism could be mutual rotation. Please, are you okay?
Oh, okay.
So that's what.
Yes, please. Thank you.
You're welcome. Yes, I saw another hand. Please, let's hear you.
Sir,
Mm-hmm.
please, mine is on the characteristics of the carbohydrate as the mutual rotation. The second point after the sugar. So with this one. No, sir, I mean the whole thing, like the way the diagram is shown and all that. So I want to ask, I don't know if in your questioning as to whether you ask us to list, maybe you say we should give some example, we should list some characteristics of the carbohydrate. Would you expect if someone should write what you have explained as carbohydrate being capable of transforming themselves from one structural form to another, will you be marked or you will want us to draw this thing here?
Oh, no. I understand that some of you have challenged with chemistry. So
thank you.
I wouldn't bother you so much about structures, but at least know some names that you could give examples to illustrate the point. I'm sure you understand that.
Okay, sir.
At least that would be a proof that you have gone through the course than you just giving me titles and then that ends it.
Okay.
There should be names. So an example of mutual rotation could be what? The transformation of what? Alpha D glucose to what? Beta D glucose.
Beta D glucose. Okay.
So that in itself could be okay, rather than you just saying and nothing more.
Sir, please, the word again. Alpha what?
Alpha D glucose.
And this is what?
Alpha. And this is beta D glucose.
Okay. All right.
And the middle one is the same as those in the
middle one.
Opening up of the chains.
So watch this. Can you see?
In order to transform to
Yes, I've seen it.
These ones suggest that this one can also open up and become this one and then
like this. Okay.
So alpha can convert itself to beta through the open chain. The beta can also convert itself to what? Alpha through
the opening chain.
So the open chain now becomes an intermediary between the two forms.
Okay.
So what it is telling you that the open chain is not stable, but rather transitionary.
Okay.
I'm sure you understand that.
Yes.
It's more or less like a bridge. So they open up, become a chain, and then quickly they either transform back to their original form or they reconvert either to an alpha or to a beta. Does it make sense?
Yes. Thank you very much.
You're welcome. Yes. I'm seeing another hand up. Madam Diana.
So I'm the one who just asked the question.
Okay, so you are fine now.
Yes, please.
Yes. Okay. All right, so let's move on. So the next one is glycosides. Glycoside formation. What are glycosides? These are the methylated form of carbohydrates or simple sugars. And how do we get them? They are methylated. Can you see the methyl group CH3? And here we are seeing CA3. So when you see these methyl groups attaching themselves to simple sugars, we call that co-compound as what? Glycoside. Are you okay? And many simple sugars are capable of undergoing glycoside formation when they react with what? Methanol. The main reagent is what? Methanol. Shall we all say it together?
Methanol.
Methanol.
So this is the point. What you are seeing here is glucose. This is a D-glucose reacting with methanol. Are you okay? And then you can see that the methanol, from the methanol, what are we seeing? An OH will take away an H. Are you okay? And then the methyl group will get incorporated onto the glucose molecule. Now, in getting incorporated, it can either be pointing down, in which case we call it what? Alpha methyl D-glucoside. If it's pointing up, it becomes what? Beta.
Beta methyl D-glucoside.
So the alpha usually has to do with the OH pointing down. The beta has to do with what? It pointing up. Does it make sense?
Yes, sir.
All right. So probably in the exam, I may give you one or two structures and I want you to identify it. So just get familiar with some of these little nuances. Are you okay? All right. These are natural forms of glycoside predominantly in plants. And actually, I'm showing you this because some of them have what we call therapeutic property. So here you have a plant, the Digitalis purpurea. Are you okay? The leaf of the plant contains a lot of these glycosides, which are being mentioned here, digitoxin, gatoxin, and gatalin. But digitoxin is often used as what? A cardiac glycoside. It's used to treat hypertension. Are you okay? It's used to. And then another plant, Digitalis lanata, which also what we call digoxin. Are you okay? The digoxin and the digitoxin, which are all sugar glycoside, are very good what do you call it? Therapeutic agent against what? Hypertension. Are you okay? So I just want to say that endogenously, living organisms are capable of producing glycoside even without necessarily reacting with what? Methanol in the outside or in the test tube. Are you okay? And they often be used as a way to store carbohydrates. Are you okay? For most plants, these are referred to as secondary metabolites. They are ways by which the plant gets rid of some of excess carbohydrates. Are you okay? So they make them less reactive, very stable, and harmless. But to humans, we can use that as what? A therapeutic agent. By preparing decoctions of the plant parts and then using them. Okay. All right. Please, any questions so far? All right. We'll move on to the next one.
Please, sir, can you please project your voice a little? Your voice a bit too low.
Oh, really?
Yes, sir.
Okay, thank you. Madam Jacinta, your hand is up.
Okay, sir, please, for the glycoside formation.
Yes.
My internet got cut, so can you please repeat it for me?
No, I was saying that they are formed when sugars, simple sugars like glucose, react, are you okay, externally with what? Methanol. Are you okay? in which case the methyl group of the methanol gets incorporated onto the glucose structure. So like, unlike before, look at this structure. We didn't have any methyl group attached to this O. It was H, isn't it? But now the H and bring what? CH3. Are you okay? We remove the H and bring what? CH3. Can you see that? And we are saying that this group, this methyl group, IUK, can attach to an OH, which is pointing down, in which case it becomes what? Alpha methyl glucoside. If the OH is pointing up, it becomes what? Beta methyl what? Does it make sense? Jacinta, are you there? Hello? Okay. So the next one is the reducing property. Shall we all say?
Sir, please excuse me.
The reducing properties.
Sir, please, I'm asking a question.
Yes.
Reducing properties.
Go ahead.
Sir, please, you said it's the metal, the
little form of sugars.
the glycoside formation.
Yes.
You mentioned that it's when glucose reacts externally with what? Metal.
No. Can anybody?
Methanol.
Is that when the glucose reacts externally with? You mentioned something. I didn't get you.
Methanol.
Methanol.
Yes.
Thank you.
You're welcome. Okay. Please, can I go on?
Yes, please.
Yes, please.
Yes, please.
Okay. So we look at what we call reducing properties of carbohydrates. Actually, this property does not apply to all. Madam Roberta, your hand is up.
No, sir, let's continue.
Okay. Not all carbohydrates are able to exhibit this. Okay, but most of the simple sugars, in fact, all the simple sugars we know, the glucose, fructose, and then the galactose, even mannose, are all capable of what? Exhibiting reducing property. Here, what it means is that the carbohydrate can reduce. By reduction, I am talking about what? Converting an ion from a higher charge to a lower charge. What did I say? I'm talking about what? The property.
Converting an ion from a higher charge to a lower charge.
Okay. So when most carbohydrates react with something like copper 2, are you okay? Copper with a charge of what? 2 plus. Copper with a charge of what? 2 plus. What does it
plus
do? It can convert the 2 plus, it reduces it to a lower charge. So from 2 plus, it brings it down to what? 1 plus.
1 plus.
Now, if it happens like that, the copper 2 plus has a blue color. Now, if it changes to become 1 plus, then what does it mean? Its color will also change. Are you okay?
Yes, sir.
So, maybe let me show you this. New share. Please, can you all see this?
I don't know.
Hello?
Yes, sir.
Can you all see?
Yes, sir.
I'm of first cannot see.
Yes.
Okay.
Yes,
So here you have the sugar or the carbohydrate, and it reacts with copper 2. Usually the copper 2 is present in what we call Benedict's reagent. That's why one of the tests for carbohydrate is what? The Benedict's test. So the Benedict reagent contains copper with a charge of and as copper with a charge of +2, its color will be what? Blue. Are you okay? When copper has a charge of +2, its color is what? Blue. Can you see this?
Blue. Yeah.
So this is the color of copper with a charge of +2. Benedict's what? Solution.
Test for sugars.
Are you okay? Then when you heat it, after heating the sugar or the carbohydrate with the Benedict's reagent, are you okay? You will realize that the carbohydrate you need to reduce the copper 2 become copper 1. And so the color will change from blue to become what? Brick red. Can you see this?
Yes, sir.
So the brick red now appear as something like this. I'm sure you can all see this.
Yes, sir.
Yes, please. Like
it's a
brown.
It's a transition between these two.
Okay.
A bit of this and a bit of that, IUK, and all that.
Okay.
So what happens that I'm showing you all this because the color may not necessarily be a one-way shot. Sometimes, depending on the concentration of the simple sugar you had, that can tell to what extent the brick red will be formed. Are you okay? So if you have a lot of the simple sugar, then you are going to form a lot of the brick red. So the color now will deepen. Are you okay? But if you have little amount of reducing sugar, then you would see that the brick red will not be properly formed, and you are likely to see any of these intermediates. But the key thing you need to pay attention to is that at least if the blue color disappeared, then that shows that there has been some level of what? Activity or reaction already. Are you okay?
Yes.
If the blue color persists, then that tells you that the sugar you are dealing with or the carbohydrate you are dealing with is what? Is not the same. And that doesn't mean that it's all carbohydrates. I've already said that not all carbohydrates are able to exhibit what? Reducing property. This is not universal to what? All carbohydrates. Are you okay? Madam Josephine, your hand went up.
Sir, you said when the blue color changes, what happens?
It implies that there has been what? Reduction. So it says that the carbohydrate you are dealing with has some level of what? Reducing properties. However, if the blue color persists after warming the reaction mixture for a while, it indicates that there isn't what? Any reduction property. Are you okay?
Yes.
Don't conclude that what your sample is not carbohydrate. No, I've already said that not all carbohydrates are reducing in property.
Okay.
So that's all. Any question before I move on to the next one? All right. Then the other thing is that carbohydrates are capable of undergoing.
So around there.
Okay. If you don't have any comment to make, kindly keep.
Question.
Yes.
It doesn't mean that the blue color is the original color.
So the blue color is the original color for. The blue color is the original color for the Benedict's reagent, because the Benedict reagent contains copper with a charge of +2. So, and +2 charge on copper renders the solution blue. So that's actually the traditional color for the Benedict's reagent. Are you okay? Yes, Madam Rebecca.
Yes, sir.
Let's hear you. You raise your hand.
Hello.
Hi.
Please, can we say this test, can it be referred to the test we normally do for the pregnant women, like the urine steps, the protein, and then the glucose? We have some colors too, like when it's plus.
Yeah, that could be. But for usually the glucose we do for using the using the urinalysis strip, are you okay? That one uses an enzyme. It doesn't use this chemical procedure.
Okay.
An enzyme.
So thank you.
The enzyme will convert the glucose to a particular form and emit a particular color. And then the intensity of the color will indicate whether it's high or low. Are you okay?
Okay, thank you, sir.
You're welcome. That's a very, very interesting question. Thank you, Madam Becky. All right. So can we move on? The next one is that carbohydrates are able to exhibit what we call oxidation and reduction property. Please watch this. In the first reduction we saw, it was a process, the reduction imposed by carbohydrates on other substances. Are you okay? But this one, we are talking about the carbohydrate itself being reduced or being oxidized. Are you okay? Now, oxidation of carbohydrates can produce 3 different compounds. Are you okay? What did I say?
Oxidation of
carbohydrates produce what?
Can produce 3 different compounds.
3 different compounds.
All right. So the first one is when you can produce what we call ardonic acid. You can also produce what we call aldaric acid. And then you can also produce what we call uronic. Okay. So please, I hope you can all see this.
Yes, please.
Okay. So following,
Yes,
so following oxidation of carbohydrates, especially most simple sugars, you can produce either what? Aldonic acid, you can produce aldaric acid, and you can also produce what? Uronic acid. Now, under what conditions do you produce any of these? The first one is that when you use mild, agents, mild oxidizing agents, you produce what? Aldonic acid. So glucose can be converted to the aldonic acid counterpart, which we call gluconic acid. Are you okay? Let me show you that one. And, please, can you see this?
Yes.
I hope you can all see that.
Yes, please.
So you can see that this glucose being converted by weak oxidizing agent to form what? Aldonic acid, which is called glucose acid. Are you okay? Okay. Let me share this.
Olivia, please mute your mics and let's concentrate.
Please, if there's noise in your background, kindly keep your mic off. You would definitely hear me. Are you okay? You don't need your mic on to hear me. Are you okay? You just need your audio on. And that one, your audio is already turned on as soon as you join the people. So just keep your mic off. You are not actively contributing or saying anything, so that you don't create any inconvenience for anybody. All right. So let me show you this. Now listen to me. If your mic turns on without you contributing, are you okay? I may permanently turn off your mic. I wouldn't want to do that, but I would want to plead with you to just be very decent and let's finish this in time. We are barely 30 minutes left and we can finish this. Much of the content has already been dealt with, so let's quickly wrap up. So here we have our glucose. This is an open chain form of what? Glucose. And it undergoes what? Mild oxidation. And look at what we form. This is what? Gluconic what? Acid. Are you okay? So here you can see that the aldehyde function is being converted to what? An acid. So this is gluconic acid. Are you okay? As we saw in the list I showed you earlier on the slide. Then we are also saying that you can convert glucose to what? Aldaric acid. Let's all say together, aldaric acid.
Aldaric acid.
Right. So under what circumstance will we aldaric acid?
Acid.
Yes, we produce aldaric acid when glucose or when simple sugars are made to undergo what we call drastic oxidation. So when they react with very, very strong oxidizing agent, when they react with strong oxidizing agents, potassium permanganate or potassium dichromate, then
Sir, please, your voice is swinging, so it goes down, it comes up. We are not hearing it very well.
Okay, so just to repeat, I said that when carbohydrates undergo aggressive oxidation, are you okay? Remember we said that in the earlier case, it was what? Mild oxidation. So you use mild oxidizing agent, are you okay? But in the case where you use drastic or let's say strong oxidizing agents, are you okay? The simple sugar, in this case glucose, is converted to the aldaric form, which we call the glucaric acid. Are you okay? And this could also happen in the lab as well as in cells. Then there's also the other form of what? Oxidation, where sometimes enzymes are employed. Are you okay? And Usually, you know, enzymes are very mild, very gentle. Are you okay? But they end up producing another form of what? Acid, sugar acid, which we call uronic acid. Are you okay? So during enzyme oxidation or enzymatic oxidation, glucose will be converted to what we call glucouronic acid. Are you okay? As you can see on the slide. So here we are seeing glucose being converted to what? Glucouronic acid. And this is how glucouronic acid, okay, usually it's in the ionic form, so we'll call it glucouronate. Okay, and this is very, very critical or useful in the body because it helps in the removal of several waste products such as bilirubin and other drugs. Are you okay? Most drugs are often conjugated. They are made to bond or bind to glucouronate. Are you okay? So that they become more soluble in the blood plasma. Are you okay? For easy removal. Are you okay? So that's one of the major roles of glucouronates within the body. Are you okay? Now, on the reduction of sugars. Sugars on reduction are formed the alcohol derivative. Remember, we said that when they are oxidized, they produce the acidic form. Are you okay? When they are reduced, they produce the alcohol form. So when glucose is reduced by reducing agent, it forms what? Sorbitol. Are you okay? When mannose is reduced by reducing agent, it forms what? Mannitol, which are all alcohol forms of what? Sugars. We call them the sugar alcohols. Are you okay? Now, fructose can also be reduced by reducing agent, but in the case of fructose, because of the ketone rearrangement, it can either give rise to sorbitol or mannitol. Are you okay? So take note of that. Please, any question on this before I finally comment on them?
Sir, please come again.
Can you come again? Yes.
Mm-hmm.
Sir, please, can you go over again?
What I'm saying is that on reduction, sugars, are you okay? When they are reduced, they are converted to their alcohol forms. So we call them sugar alcohol. It's just like I said earlier, that on oxidation, the sugars are converted to their acid forms. So when you oxidize glucose, you either form gluconic acid, glucaric acid, or glucuronic acid. In the same way, when you reduce sugars, you form their alcohol derivative or alcohol companion, which we often loosely will call alditols. So an example is this case. If you take glucose and reduce glucose using an appropriate reducing agent, you form sorbitol, which is the alcohol form of what? Glucose. If you take mannose and reduce it with a reducing agent, you form what? Mannitol. Are you okay? If you take it yields either of sorbitol and mannitol because of the orientation, are you okay, of the... Are you okay?
Yes, please.
All right.
Yes, sir.
Just a bit of comment about the sorbitol and usually in diabetics. Usually in diabetics, one of the common characteristics of diabetics is that there is constant what? Hyperglycemia or prolonged hyperglycemia. Which means that there's high level of glucose in most times in their blood circulation. And this will force glucose into tissues which otherwise may not have been storage site for glucose. One of such example is that usually under prolonged hyperglycemia, some glucose, are you okay, are forced through osmotic pressure, are you okay, into the aqueous humor of the eye. And there, the glucose may not be oxidized, but rather reduced from glucose to what? Sorbitol. Are you okay? As sorbitol accumulates, what happens? They influence or they negatively affect the optical density of the eye, of the aqueous humor of the eye. And so the ability of the aqueous humor to bend light onto the retina becomes impaired, and people develop complications. One of such is what we call cataract. I'm sure you have heard of it.
Yes, sir.
Cataract is a clear case of sugar being reduced at the wrong side of the body. Are you okay? So cataract occur as a result of unusual accumulation of sorbitol. Are you okay? All right. The last one about the chemical characteristics is polymerization.
Please, a question.
Yes, madam.
With the reducing properties of the carbohydrates, does this explains why they tell us that every food we eat has a bit of alcohol in it?
Not necessarily. Not necessarily. I think that analogy stems from the fact that everybody has a bit of alcohol in us, not from the food we are eating, but a bit of what we call natural alcohol within our bodies. Madam, are you okay?
Yes, sir.
So that alcohol is already in us, not that we are taking it in. Are you okay? And it's as a result of the various metabolic processes that occur for different food substances. Are you okay? Or different biomolecules. Are you okay? That's why loosely we would say that everybody has a bit of alcohol. But even with that alcohol, it doesn't refer to what we loosely call alcohol, like ethanol. It's not necessarily ethanol. What we are sharing here, sorbitol is not ethanol. I'm sure you understand that, even though it's another form of alcohol, but it is not ethanol. A lot of the time, people will say this to clear or to encourage the reason that drinking ethanol, it's not bad, because ideally you already have some in your body. So your body needs it, and that your body is already used to it. So taking more wouldn't really affect you, because if it could kill you, the ones inside you may have killed you. I'm sure sometimes that's what people say as an alibi for taking ethanol or alcohol as a drink. But that is not it. Are you okay? Your body does not contain ethanol. It contains some alcohol though, but they are not necessarily ethanol. Please, are you fine? Yes. Madam Asamau.
Sir, please, good evening. Sir, please, with the intake of the ethanol, does it have any effect on the actual alcohol within the body?
You say that again.
Does it have any link with it? With like taking the ethanol? Does it have any effect on the body?
Yes.
The body which produces its own alcohol.
Yes, plenty. In fact, let's say this. Let's be very frank with ourselves. If the body naturally produces its own alcohol, and then you also add ethanol to it, don't you think you are increasing the alcohol level within the body? And that comes with repercussions. Because what the body needs, it can produce by itself. Why must you add on to it?
Okay. Sir, please, the reason why I'm asking this question, I was working with a certain doctor somewhere. Anytime he's about to conduct an OP, there are some cases the doctor himself requests the client to go and take in small ethanol before, like for some weeks before the fellow comes back for that procedure. That's why I'm asking if it has any link with it.
Okay. Probably he may be the best judge. Are you okay? But did you ever ask him why he makes people do that?
Yes, I did, but he just told me that's his secret. So he couldn't tell me much. That's why I'm asking.
All right, very interesting. Very interesting. All right, Madam Angela, your hand is up. Thank you, Madam Ali. Thank you.
You're welcome.
Madam Angela, your hand is up.
Hello, sir.
Hi.
Sir, please, I heard something about the reduction of sugar, and I hear it again because my network went off. What I heard was he said when sugar is reduced, it forms alcoholic compounds also. So that particular part, I get it.
Okay. So thank you. Okay, Madam Angie. So Angie, in a nutshell, what we said was that when carbohydrates are, or simple sugars, let me say so, undergo reduction, they form the alcohol derivative of their original form. So if glucose goes through reduction, ideally we expect it to form what we will call glucitol. But there's nothing like glucitol. The real name is what? Sorbitol. Are you okay? And then in the same way, if mannose undergo reduction, it forms what we call mannitol. Please, are you okay?
Okay, stay.
All right. So can we move on now? All right. Thank you. So we go on to the last bit about the chemical properties, which is what? Polymerization. And by polymerization, what we are trying to refer to is that simple sugars, two or more simple sugars can join and form either a disaccharide, oligosaccharide, or polysaccharide. Are you okay? So simple sugars can join together by shedding of water, as we can see in this reaction. And then they form a are you okay? Usually, during polymerization, the linkage between the simple sugars is termed as what? Glycosidic linkage. Are you okay? Now, please pay close attention to this. This is a condensation process. What do we mean by condensation? It means that during the process, water is lost. That's H2. How do we get the H2? One of the coming group or unit will bring an OH, and then the other brings an H, and then it becomes H2 and is shared off. Now, as they leave, are you okay? This creates a two-bond system across the oxygen molecule. Are you okay? And so that's what we refer to as what? Glycosidic linkage, which holds the individual simple sugars together. Are you okay? Now, the form, nomenclature of the glycosidic linkage depends on the carbon atoms and the orientation of groups across the carbon atoms. Here, we can see that the bond is between carbon 1 on one group and carbon 4 on the other group. Are you okay? Now, the carbon 1 has OH, which is oriented in the alpha config. So we'll call the glycosidic linkage as what? Alpha 1,4 linkage. Are you okay? Let me say this again. the nomenclature for the glycosidic linkage, which occur between simple sugars during polymerization, depends on what? The orientation of groups and the kind or the positions of the carbon atoms involved in the linkage. In this case, we have carbon 1 from the first simple sugar and carbon 4 from the second one involved in the linkage, as we can see here. That being said, the carbon 1 has OH in the alpha orientation. So we'll call it what? Alpha 1,4 glycosidic linkage, as we can see here. Please, any question? Now, this is for maltose, and maltose contain what? Glucose and another glucose. Are you okay? So it means that when you digest maltose, you produce glucose units. Are you okay? Now, let's move on to another one. Let's see. Let me show you this. Okay. Now, there's also another disaccharide, which we call sucrose. And you can see that the glycosidic linkage is between what? Carbon 1, and this is carbon 5. Are you okay? Usually, you would start numbering from here. 1, 2, 3, 4, 5. So this is also what? Alpha 1, 5 glycosidic what? Linkage. Now, this is lactose. It consists of galactose and what? Now, in the case of the galactose, the OH is in the beta configuration. I'm sure you can see that. Okay. And it's between 1 and 4. You can start counting from here, carbon 1, 2, 3, and 4. So we'll call this as what? Beta 1,4 glycosidic what? Linkage. Okay. Are you all fine?
No, sir. No, sir. No, sir. No, sir. No, sir. No, sir. For this year.
What is the problem?
And to share, I said.
Seriously.
Confusion. I
Very mindful. No, be very mindful.
Understand this twice.
Hello, class. Be very mindful of your confession. You are aimed to learn this. Are you okay? So then just throw in the towel. Just exercise restraint. Follow me carefully. If there's any problem, you raise your hand for further clarification. Don't just discourage yourself.
Okay,
okay, with those comments. They are not good and unsavory. Yes, Madam Angela, your hand is up. Where did you miss it?
Hello, sir.
Hi.
Sir, please, can you give us some examples of like monosaccharides? Maybe fructose is a monosaccharide, and disaccharides and the polysaccharides.
Okay.
Because
yeah, go ahead. I'm listening. Hello, Angie.
So please, it seems they are all like I know the difference between the disaccharides and the monosaccharides and
yeah, I was going to come to that, but prior to that,
the polysaccharides.
Yes, so, prior to that, I wanted to explain how glycosidic linkage occur. Are you okay?
Okay.
If you want names of monosaccharides, I could show you. So let's go back to the slide. Okay. Please, for those of you with your hands up, kindly bear with me. Let me just Angie. These are what we refer to as monosaccharides.
Hey, what is student for safe fridge, man? Can you finish the mammy penny with my face here?
Okay, so Angie, these are the monosaccharides. These are simple sugars, we call them simple. They stand alone. Usually they are not joined in any way to any other sugar molecule. Are you okay? So you can see here glucose, fructose, galactose. These are the commonest ones. Of course, there are more. We can have mannose, we can have what we call sorbose, are you okay? Xylose, and so on and so forth. All these are common examples of what we call simple sugars. Now, and they are technically called monosaccharides. Now, disaccharide, what does it mean? Two sugars, two simple sugars which are joined together. So common examples of disaccharide would be what? Sucrose and what? Lactose. Are you okay? You could also talk about maltose, which I showed you earlier. Are you okay? We can also talk about what? Maltose, which also contains what? Two glucose units, which are joined together. Are you okay? So these will constitute what we call disaccharide. Then we have what we call oligosaccharide. Oligosaccharides usually contain between 3 to 11 monosaccharide units. Are you okay? 3 to 11 monosaccharide units. And then the last one is what we call polysaccharides. These are common examples of polysaccharides. Cellulose, starch, glycogen. Are you okay? Chitin, and all the rest. They are all forms of what? Polysaccharides. Are you okay? These ones contain 20 to infinite number of what? Monosaccharide units. Angela, are you okay now? Okay. Now, that being said, apart from the monosaccharide, all the other forms of carbohydrates will contain what? Glycosidic linkages. Because for us to form disaccharide, we need two monosaccharide units held together by glycosidic linkage. In the same way, for oligosaccharide, we need to form glycosidic linkage. For polysaccharide, we need it even all the more. That's why I was trying to explain what glycosidic linkages are, how they are made.
Yeah,
Are you okay now? All right. Let me take, I think there was another person who said, Madam Diana, your hand is up.
Sir.
Hi.
My question has to do with this saccharides you are taking us through, the sugars and these diagrams, complicated ones.
It's not complicated.
My question, we are trying, we are following small.
Yes, but don't say they are complicated. They are very simple.
Okay, sir. Thank you. So my question is, in case you are to set questions, will you get set question from this place too?
Definitely. Every slide counts, every content matter. So please don't learn in isolation. That's why you come for a lecture. And sincerely speaking, let me tell you this, please. I realize that many of you are too fixated on marks. But I'm not sure you have come to school for marks. You have come for training. You have come for information. You have come principally for knowledge.
Exactly, sir.
So if I were you, I would concentrate on trying to understand as much as possible from every lecture, because that is what will make your practice more efficient. Are you okay? And that is what we need.
Yes, sir.
But at the end of the day,
sir, we are doing that too, but sir, we are actually, as you said, you are very right. We are actually learning and trying our best. Just as you mentioned, most of us are not this subject inclined. But as you said, we are following small. I only want to be sure that your questions, some of your questions will come from this topic per se, or this.
Generally speaking, I'm going to ask questions on biomolecules. Be ready for some.
That's our hospital.
Madam Lee, Mrs.
The lady talking.
Mrs. Amuzu, please, if I see you unmute yourself without asking a question. I will eliminate you from the class, or probably I'll mute you permanent. If you can hear me. All right, Madam Diana, are you okay?
Sir. Yes, sir.
Wonderful. Mrs. Uncle, your hand is up.
Yes, sir.
Yes.
Sir, please, with the drawing of the sugars, is there any formula that you follow to be able to know where the H will be, where the CH will be, where the HO and the rest? We would really love it if we know how to draw them.
Well, like I said earlier, I didn't want to really make this too much of a bother to many of you because of the chemistry and all that and what I had heard earlier and blah, 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 blah. That's why I'm trying to just make everything very simplified. Because sincerely speaking, if we have to go through these notations and all that, it will be painstakingly slow.
Hello. Hey.
So what I would advise, please hold on, let me answer. What I would suggest, as you can see them now, try and it's very weird for me to do this, but memorize it. Are you okay? Would that be okay for you, Madam Uncle?
Sir, I didn't hear, your line was breaking.
Yes, I'm saying that honestly, I didn't want to really run you through the chemistry dynamics of the whole thing because that will end up really confusing a lot of you. And prior to this lecture, I was made aware that many of you are not really chemistry biased and all that. So I chose this topic with a lot of caution. And sincerely speaking, the content I had to be a bit picky and choosy. Are you okay? To really get content for you that you can easily relate. So yes, I can honestly take you through all that from the open chain to the, what we call the hemiacetal formation, and then how the cycle closes up. I can do that, but I don't want to really lose you and lose your interest. Are you okay? Because it's a bit complicated than this. Madam,
yes, sir.
Are you fine?
Yes, sir. I'm asking this because if I have a compound being drawn out like this and I'm asked to mention what it is, I can't really say this is a glucose, this is a fructose or that.
Okay.
That was what I was just asking, just by the way.
So generally, this is how I would want you to really learn that. Let me see if I can get you a simple demonstration. Usually, most of the simple sugars, are you okay, relate so close, but they differ. Are you okay? They differ usually slightly with respect to the arrangement on one carbon or the other. And so what you can do is that you can master one, then on the basis of what you know as a difference between one and the others, then that will guide your presentation of the others. Are you okay? So, Madam Uncle, you let me show you this. Oh, where is this? Where is this? Okay. Okay, let me use this one as a case. I'm still seeing two hands. Please keep your hands up. I'll come to you. I'll come to you. Just bear with me. Let me answer this question fully. Perhaps it may even answer some of your burgeoning questions. Mrs. Roberta, can you see this screen I'm sharing with you?
Yes, sir.
Now, this molecule distinctly is for fructose. Are you okay? Fructose is the only monosaccharide with a 5-sided ring. Can you see the 5 sides?
Yes, sir. Yes, sir.
Yes. Now let's look at glucose and galactose. The glucose, okay, there's an alpha D glucose because the OH is pointing down. Can you see that? Okay.
Yes, I can see that.
Now there's a beta galactose because the OH is pointing up. Can you see that?
Yes, sir.
Okay. Now the main distinction between glucose and galactose is on carbon 4. Can you see that? They all have the same on carbon 1, carbon 2, carbon 3. Carbon 2 and carbon 3 for galactose are the same, and glucose. Can you see that?
Yes, sir, they are the same.
Yeah, but they differ for what? Carbon 4. You can see that for glucose, OH is pointing down, or for galactose, is pointing what?
It's pointing up.
So we say that usually we call them anomers. They are anomeric to glucose and galactose are anomers, and they are anomeric to each other on carbon 4.
Or
we can say they are anomeric to each other with respect to carbon 4. I didn't want to go into all these, okay, but at least if you have asked, maybe I need to a simple way of explaining it. So what I would advise is that with this logic, you don't have to memorize galactose. You have to memorize what? Glucose. This is the typical structure of glucose. Then I know that galactose is what? An anomer of what? Glucose with respect to carbon 4. So when I get to carbon 4, what do? I flip it over.
Oh, okay.
Does it make sense?
Yes, sir.
Yes, sir. Please, sir, where do you start to count?
You start counting from here. There's carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. Are you okay?
So why not the other side of the pentagon?
You mean from here? Or from here?
No, the other side. That one circled.
This one?
Yes.
No, this one is oxygen. It's not a carbon atom. It's an oxygen.
Oh, okay.
So it's not part of the carbon. It's only joining the carbons together so that the
Thank you, sir.
You're welcome. Is it better now?
Yes,
sir.
Okay. So in the same way, maybe as another clue, you could also look at glucose and mannose. Now, glucose and mannose are anomeric to each other with respect to carbon 2. So in the case of mannose, what do you expect? It will have everything that glucose has. But when you get to carbon 2, what do? You flip it over. So OH should be here, and then H should be down. Are you okay? Let's uncle. Are you there?
Thank you, sir. Yes, I'm okay.
All right. So you can check this out. There's glucose and there's what? Mannose. Like I said, on carbon. Can you see this? I hope you can see this.
Yes, sir.
So on carbon 2, just forget about all these strings and all that. I'm just trying to point you to. So on carbon 2, you see that glucose is pointing down. But mannose is, so just master the anomers where they are anomeric. Are you okay?
Okay.
This is actually the open chain structure. Are you okay? So the OH is pointing to the right and the H to the left. But the mannose, the OH goes to the left and then the H to the right. So they are anomeric with respect to what? Carbon. Are you? All right. So
thank you, sir.
You're always welcome. All right. Now let me attend to the other two people. Madam Adom. Is it Adoma or Adom?
No, Adom. Sir, please just Adom.
Yeah. So great. Let's see. Oh, great.
So please, it's not about it's not a question, sir. It's a suggestion.
Yes.
So please, I tried to get into the class from 6 o'clock. I just got in. So someone like me, I didn't hear anything. So please, I was requesting that next time the next class, it won't be difficult for some of us because some people still even are not here. They weren't able to get in.
Oh no, I don't know why they weren't able to get in. If it were a network problem, then that's okay.
No, they'll say that the host hasn't allowed you yet.
My dear,
the host will allow you.
Let me tell you, as we speak now, it's only 2 people in the waiting room, and I've admitted all of them. Usually, along the line, as the lecture goes on, people still keep coming in. I'm very, very much aware. And so I keep admitting people into the class every now and then. Are you okay? Even among those who have already joined the class, sometimes I know for network problem, connectivity breaks, and they have to rejoin. And I keep admitting people. Are you okay? So,
yes, so it's happened to me. So today I didn't get to hear anything from you.
Well, no problem. I don't know when you signed it anyway. But welcome.
I signed in from 6 o'clock. So I was putting this on our page that you should give me another link because I still can't get in. You are not allowing me.
Anyway. All right, Madam Adom, you are welcome. Let me take Mrs. Esther. Please, your hand is up. Madam Adobia, please hold on. I'll attend to you. Mrs. Esther.
Okay, thank you, sir, for the opportunity. Please, I want to clarify something about the polymerization. You said that simple sugars come together to form monosaccharides.
No, please. They come together
to form disaccharides, sorry.
Or oligosaccharides.
The simple sugars are called the monosaccharides.
You say that again?
I said the simple sugars. They are the monosaccharides.
Yes.
And they come together, 2 of them come together to give us a disaccharide. And the linkage between the, let's say, example, glucose and the fructose coming together. So the linkage there is called the glycosidic linkage.
Excellent.
And the process by which they come together is a polymerization.
Okay, let's see.
Okay. For you to get the disaccharides, you also need 2 of the monosaccharides group.
Yes, to join.
The simple sugars to join,
yes.
Giving you the disaccharides.
Yes.
And that linkage, is it also called the glycosidic linkage?
Yes, please. They all need, because...
Okay, so that one runs through all.
Yes. Anytime you have 2 or more of the simple sugars joining, they will always have to join by glycosidic linkage. Maybe one last thing for the sake of our dear sister who just we've also said that the